Okay, so the big discussion is questions 4 and 5. So the focus is on Usain and the speed, right? That was what we were after. How fast did he run? And we decided he ran an infinite number of speeds, but we just calculated one number, so we want to really be understanding what does that one number mean. Okay, so purpose of in this animation, and what is your race like, and how does it help us understand Usain's race? Okay, so what distance did Usain travel? 100 meters. What about Emma? 100 meters. Okay, how long did it take Usain to do it? 9.58 seconds. What about Emma? 9.58 seconds. Good. Okay, that's important. All right, and then and we know his average speed was the 10.44 meters per second. So again, the focus is on Usain. What's the purpose of having Emma in the animation? Veronica, what do you think?
Emma's going at a constant speed, so having her there is showing how his speed increased and decreased.
Okay, so it's first of all we can see how he's speeding up. Right, he's speeding up, and then he slows down a little at the end. You see that right there? Actually, get their top speed before the finish line, and they slow down a little bit in those races. So, okay, what else? Why Emma in the animation? What's the purpose of Emma in the animation? Okay, go ahead, Jim.
So basically, she represents like that average 10.44 meters per second.
Okay, yeah. So Veronica said she ran at a constant speed. What constant speed did she run?
10.44.
She ran 10.44 meters per second, right? That was that number that we found for Usain. Okay, yeah.
And she started before the start line, so she was already at that speed.
Right, so from the very 0 meters all the way to 100 meters, she is going that constant speed of 10.44 meters per second. Exactly. Okay, so how is that helping us understand Usain's race? What's the point of this? Astrid, what do you think?
It's showing us that he doesn't run that speed.
Okay, but that's the number we got for him, right? When I said what is his speed, you told me it was 10.44 meters per second. Okay. So this is really helping us understand the meaning of average speed. What is the meaning of average speed? This Alyssa.
I think in this context, the average speed is how he slows down and he goes so fast to where that's kind of like the medium.
Okay. Like the median in between?
Yeah.
Okay. Yeah.
I think it shows that, like even though they're going the same distance and the same time, they both have different speeds from one another.
Okay.
And I guess in a sense, like Usain goes faster than 10.4 at some point.
Right.
He has to catch up.
Right. Okay, but going back to the beginning, I said, how fast is he going? And you told me 10.44 meters per second. So what does that number mean? Winston?
It's like the constant speed that you would need to travel, the speed that you would need to go at in order to travel the 100 meters in the 9.5 seconds.
Did you hear that? Nailed it, right? So that's the point of Emma. Emma is showing us what constant speed would he have needed to go, what, to cover same distance in same time. So that's what that 10.44 meters per second. It's like this kind of equivalent constant speed that tells us at what constant speed you would cover the same distance in the same amount of time. That's the point. So that's number 5. Okay. Okay, so part 2. Suppose you're driving a flat highway with a cruise control set at 70 miles per hour. So we started by this first part was understanding average speed. And what is average speed? Average speed is a The constant speed, right? To cover the same distance, the same amount of time. All right, well, what about what's constant speed? All right, so her two is about, let's unpack kind of what constant speed is. So what's the meaning of the constant speed, 70 miles per hour? What do you think? What does that mean? What is that?
From start to finish is 70.
Okay, but all right, so, and what does 70, exactly what does that number 70, if it's miles per hour, what does the 70 mean?
How many miles
However miles,
would travel every hour?
is that right? How many miles you would travel every hour? So for every hour that goes by, you would cover 70 miles. Is it true? It's not true? Every hour that goes by, you wouldn't cover 70 miles?
Well,
I'm asking if it's true. Is it true? It's true. It's absolutely true. But, is it a good definition for 70 miles per hour? Okay. So, the next couple of questions kind of will lead you through that. So, it tells you that you know that if you went for an hour, you'd go 70 miles. Does it tell you anything else? Look at the next question. Do you know how far you go in 2 hours? Do you know how far you would go in 5 hours? How far would you go in 5 hours? Okay. Do you know how far you'd go in half an hour? In a tenth of an hour? 7 miles in a tenth of an hour? What about any other durations of time? Are there any other variations of time that you would know how far you would go if you were going 70 miles per hour? Only 1 hour?
Or any hour?
What's that?
Any,
What do you mean?
like you could pick any segment of time,
Right? And
multiply it or divide it.
yeah, so it doesn't just tell you how far you go in 1 hour. It tells you how far you go in any variation of time, right? In any variation of time, you know how far you go. So how far do you? So we could call any variation of time. We could call that DT. I'll get this thing working. So given any variation of time, dt, how far do you go in that variation of time? It means you go 70 miles every hour. That's what it means. Okay, so you could say that's a meaning for it. It's just a narrow meaning. Okay, Veronica. So given any variation of time, your speed is 70 miles per hour. You're kind of using the term to define itself, right? So that was a good start. So given any variation in time, what do we know? So we'll call that the variation in distance. How about, we'll call that dd, or capital D. What would the variation in distance be for any given variation in time? Lydia, what would that be? Go back. How did we get, so like how far did we went in 2 hours? How far do we go in 5 hours? How far do we go in a half an hour? Now we're saying, how far are we going in any variation in time? She said, is it 70 times dt? You agree with that? Two hours. How far do we go in 2 hours? 40. How far are we going? 5? far did we go in a half? So this is like the DD, right? And this is like the DT. So what would it be? 70 times. So, so given any variation in time, the variation in distance would be 70 times as much as that variation in time. So now that's a broad meaning, right? Because it tells us a lot more than just how far you would go in 1 hour. It tells us how far you go in any amount of time, right? So that's a good broad meaning. All right, so now I want you to practice on number 4. So write out in words a concise statement that explains what $2. What are we at now? We're like $2.75 now. So if you want to change it to $2.75, back when I wrote this 2 years ago, it was $2.10. So what does it mean that gas is $2.10 a gallon? That's a constant rate of change. All right, let's see here. Alyssa, what do you think? What does that mean that gas is? What's a good broad meaning that gas is $2.10 a gallon? Yeah.
In any number of variation of, or in any variation of the number of gallons of gas, you know, the variations of the cost.
Okay, and what is it?
DC equals 210 times DG.
Okay, so can you put it all together in an English statement? So you're not doing a hybrid between English and the math. So put the whole thing together in words.
The cost equals $2.10 times the variation of gas, or gallons of gas.
Okay. Let's see, Astrid, what do you say?
Same thing, just a couple different.
Tell me.
Given any variation in gallons, DG, the variation in price of dollars is 10 cents times DG.
What do you guys think?
$2.10.
Yeah. Jason, what'd you put?
So cost is equal to, I didn't put anything really. I just put cost is equal to. I try to like look at it through like the DD and all that.
Right.
So I did like $2.10 for every gallon will give you the cost.
That sounds like the only thing you know is how much for 1 gallon, right? That's it. You know what I mean? That's like $2.10 for 1 gallon.
So for any variation in the number of gallons.
Right.
So for any variation in the number of gallons.
Right.
The cost will be $2.10 per gallon.
$2.10.
Every variation. $2.10 variation in cost.
What do you guys think? So it's a good start. For any additional number of gallons that you buy, or any variation in gallons, what can we say? Alyssa, did you say yours yet?
No. I said the variation in price was equal to 210 times the variation in gallons.
Right. So then the resulting increase in your cost will be $2.10 times whatever variation of gallons you have. Does that make sense? Right. So here it's $2.10. So how much is 2 gallons? Or an additional 2 gallons? $4.20, right? How much is an additional 10 gallons? $20. How much is an additional half a gallon? $1.05. right? How about a tenth of a gallon? So this is what it's about right here. This is what it's about right here. Given any additional gallons that you would buy, or any number of gallons that you would buy, you know what? You know that the additional cost or the cost of the gas would be?
Would be the number of gallons multiplied by $2.10.
That's what it is, right? So to get the additional cost or the variation in cost, every time it's just $2.10, the constant rate of change, times whatever the variation in gallons was. So if you're kind of struggling with it, it just goes back to this table, which is really easy to do, right? You're just telling me instantly. You're telling me how much it would cost for this number of gallons. What are you doing? You're just multiplying by 210 each time. That's how we frame that meaning for that constant rate of change. That no matter how many gallons you pick, you multiply by 210, it gives you that additional cost. So rather than trying to memorize what I said, think about the table. That's where it comes from. It comes from, we can pick any number of gallons, and we know exactly how to get the additional cost. We multiply by 210. That's how we frame our meaning for constant rate of change. Okay, so why don't you get started on this next one, and then I'm going to pull up a blank GC window. We'll do just a little bit with GC today, and then Tuesday we'll spend a lot of time learning the basics of GC. GC is graphing calculator. It's the software that we're going to be spending a lot of time working with. So flip it over, and so let's talk as you work. Talk as you work. Compare answers, compare ideas, check with each other. Okay, Astrid, how did you find the constant rate of change? How did you find it? How did you do it?
I had to find how much was lost first in those 40 minutes.
Okay, so the first thing about graphing calculator is you can just use it as a computational device, just like a normal calculator. So I can all that stuff that I can do it all at once. So how am I going to find the constant rate of change?
How much you lost in 40 minutes.
Okay. So tell me the nuts and bolts of that. How do I find that mathematically?
Well, was between 35 and 75 minutes.
Okay.
So that's 40 minutes.
Okay.
And we went from 41 to 28%.
Okay.
So that would be -13 over 40.
And how do you get the -13?
It's negative because you're losing. You lost that.
Okay. So I'm gonna type something in that's gonna do all that stuff that you're explaining. So what should I type in? Like I'm gonna set up an expression to get that constant rate of change. So how did you get you say negative 41?
No.
Negative.
+40.
And negative. You said negative. You said also then the change in the percent was negative something?
13.
And where did the negative 13 come from? What mathematical statement? What did you do in your brain?
-41.
What is it?
41
But you said it was negative, right? So is it 28 minus 41, and then what?
And then 75 minus 35.
75 minus 35. Is that right? 28 minus 41, 75 minus 35. Is that what you meant? Okay. What do you mean?
Parentheses around that.
Okay.
Around 21. At the beginning.
Okay.
28, and then 41.
In order to do it.
So parentheses at the beginning.
Actually, don't need the parentheses. Just tell me why you want the parentheses. To do what?
Because we're gonna
Divide.
by
Divide by what?
by 75 minus 35.
-75 35. Yeah, so you can set up expressions like that. And then if you make a mistake, it's just like a word processor. You can copy and paste, you can highlight stuff. So if I did want parentheses, I could have highlighted that parentheses. Trying to highlight just the top here. All you need is the left parentheses. Whenever you just do the shift 9, it gives you both. You don't have to close it. It always will close it for you. Okay, so then we got -3 point. Did everyone get -3.25? Okay. So what does that number mean, Jason?
It means that for every minute,
Okay, so in 1 minute, how much does the percent change?
-0.325.
Right. And in 10 minutes, how much does the percent change?
-3.2.
And in 100 minutes.
32 or -32.
Okay. Let's see. Is there any other easy ones? How about in it's 1/10 of a minute? So these are what changes in time. And these are the resulting percent changes. So given that table, what is the meaning of the -0.325?
The battery decreases for every minute. For any variation.
For any time, or any variation of time, right? For any variation of time. The battery does what?
Decreases.
The battery percent decreases by how much?
The number of minutes multiplied by -0.325.
Good, yeah. So to get how much the battery changed, it's that 0.325 negative times whatever change in time you have. Okay, cool. All right, so what does it say next? So now we're gonna start a graph of the situation. Our independent variable is gonna be time, how much time has gone by in class, and then the dependent variable is gonna be the percent of the battery. And so first we're gonna start by plotting those 2 points. So in GC, so we're gonna learn all the stuff about GC, but this is real, just a few quick things here. To plot a point, you're going to do Control-2. You'll get lots of practice, so you don't have to. But Control-2 gives you one of these, and so we're going to plot the first point. And what will the first point? If our independent variable is time, and our dependent variable is percent of the battery, then Lydia, what's the first point?
The first place.
35. And
And then 41.
41%. Hear that? Okay, so then once I hit that, so we've just told GC to plot this point, and why is there no point? Yeah, look at your scale. I've got like pretty much 1 to 10 for both X and Y. So I need to zoom out. So basic zooming, here's our basic zoom buttons. Do I want to zoom out or in? I'm going to zoom out. That's the one on the left. Until we see it. Okay, so notice it's red. We can change the color. My favorite color is blue, so I'll make it blue. Okay, there's the point. And so then next point. Alyssa.
75.
Yep, so I'm going to do Control-2 again, and I want my X to be 75 and 28. So what do we have? We've got two quantities in the real world varying together, right? Time is going by, and as time goes by, what else happens? Yeah, so time, the value of the current time since class started is changing, and as that changes, the percent battery changes. So we have two quantities changing together, right? Two changing together. So then what does this point mean in that situation? What does that blue point represent, Veronica? This time is rolling, right? That's a variable, right? Amount of time in class, that's a variable, that's changing. And as that variable is changing, the amount of time, the battery is going down, your battery's going down. So we got two quantities changing together. So in light of that, what does this point mean? The initial point? But that blue dot right there represents, it's kind of like it's kind of like if we, maybe that's what initial point meaning, like that's when you looked at your watch and you looked at your computer. So yeah, you can call it an initial point. But what does that initial point signify? What does it represent?
That when you're 35 minutes in, your battery life is
Well said, right? So that point is the representation, the visual representation of if we paused time at 35 minutes into class, we know our battery's at 41. And likewise the other one. Okay? So from that moment in time at 35 minutes in to 75 minutes in, we have a variation or a change in time, right? So I want to show here what mathematical statement would produce a line segment on the displayed graph of the relationship of variables p and t that represents the change in time. Okay, so basically what I'm saying is I want a mathematical representation of this right here. Ready? So here's this at 35. Well, now time goes by. So this is it was so good until the end. I thought about it too much. Okay? So I want this, so what is this line segment? This line segment shows what? It shows how time varied from 35 to 75 minutes in class. Okay? Now I want rather than me drawing it with my pen, I want GC to draw that for us. So what GC is, it's not a computer language, right? We're not learning how to code computer programs. We tell it the mathematics, and it displays what we tell it. So what we need is a mathematical representation of that. If I type in over here the mathematical representation of that which I just drew, it'll draw it for us. It'll show it. So before we get to what I'm going to type into GC, let's ask ourselves, what is that segment, right? So when I drew that segment, what did I draw? What did I draw in terms of the two quantities changing together? What did I draw? Yeah. Okay, so so you're saying x is between 35 and 75. Okay, so that may be part. But like when I was drawing that black line, what was I representing when I drew that on the graph? What was I showing? Okay, I'm showing a change in time. Okay, so your answers are all good. You're relating it to the context. I like that. But so apart from the context, just the graph. Suppose there was no context. If I draw a segment like this, a line segment on a graph, what am I drawing apart from the battery and the minutes? What does that consist of? What's it? Yeah, so what I'm drawing, how many points am I drawing? Yeah, see, it just takes too long to do it that way, right? How long would it take to draw infinite many points? Yeah, it would take way too long to do that. So what we do, right? So these are just what I've really represented is a bunch of points. Who wants to do this, right? So instead we just go, whoosh, and we know in our mind, oh, that was just a fast way to show a zillion points, right? A zillion points. So what we want to do over here is then we want to tell GC which points we want to graph. That's the whole point of the mathematical statement is going to be a set of points. So part of that mathematical statement, Veronica said, is going to be what? Does this help us to find those points on that segment? Okay, is that it? If I just put that in, will it show us that line? For y equals 41? So GC doesn't know what you mean by dt. Yeah, so it doesn't know dt, but it knows x and y. If you use x, it knows you're talking about x values in the graph. And if you use y, you're talking about y values in the graph. So it knows x and y, it doesn't know dt. We could define dt and use it, but it doesn't know anything about dt related to the graph unless you define it that way. So what about this? Does this define the points I want? Yeah. All the y coordinates of those points are 41. And we want every point that has these x coordinates. Okay, so here's what I'm going to do. I'm going to do exactly what you said. There we go. All right, let's come back here. I'm going to start a new line. And I'm going to say y equals what? 41, comma, 35. What do you think? Is it going to do it? Yeah, we've correctly defined the set of points that we wanted. And so mathematically, right, that's just a mathematical statement. That's not computer code. That's just a mathematical statement defining a set of points. So what do we do? Bad color. Let's do purple. Is it pink or purple? Fuchsia's more red. I'm a color expert. This is like exactly halfway between pink and purple, is it not?
Yeah.
Tricksters. Okay. So now I want you to, suppose then we wanted to represent, as that happened, well, we saw a change in the battery. So what would, everyone, so now don't talk, everyone do it. So what should I write in the next line to show as that had that duration of time, we saw this much change in the battery percent? Everyone do it on your own.
So I put x is equal to
Okay.
negative 13.
-13.
And then comma 41 less than or equal to, if you do y, or is it still x? Oh, well, since it's a variable, it's x, right? We'll do x. And less than or equal to 28.
So it's just saying all points that have an x coordinate of -13, such that x is between 41 and 28. Okay. You good with it? Alyssa, you agree? No? What do you say?
I say x equals 75.
X equals 75. Okay.
With 28, that's equal to y, equal to 41.
We gotta make them different. Okay. Jason, you want to stay with what you had, or you want to change? So you stay with what you said?
Well,
So what are true about all these points? So we got to think about. So what we're doing is we're writing all these points. So like, what's that ordered pair right there? Winston, what do you think?
75,
This one? Second one? You agree with the second one?
Yeah.
Veronica, you agree with the second one? Jason? Here, outnumbered here.
it's because like I was confused, but then it didn't make sense because we have to start off from this.
Yeah, so think about how ordered pairs work, right? So this one at the very bottom, what's that ordered pair? What is that? If you were just to write that point, what would it be? Very bottom. So actually that was, the very bottom is the one we already had. So what are the coordinates of that point at the bottom of our segment?
It's like 75, 35.
75. Actually, 75.35 is this one up here. And that's good. I'm good. So that one's 75.35. Right? Is that right?
Yeah, so we're gonna go.
No, that's 75.41, right? So that one there is 75.41.
And then we're gonna go 75, 20.
28, right? And then we want all the points in between. So what's the x value of all those points?
Isn't it always gonna be 75?
Yeah, it's always going to be 75. And what about the y value?
It's gonna be between 41 and
48, 21, 48. So, you see that? So the x value is always going to be 75 for those points. And then y is going to vary from 28 to 41. I think. Yeah, so here, so you said x is negative 13, but then you said x has to be between these two. That's impossible, right? So you can't have, x can't be negative 13 and be between 28 and 41 also. So yeah, so that second one is, let's see. Got it. Yeah, so if your statement doesn't graph anything or doesn't make sense, it'll tell you that. So it says undefined. But then the one that we got it displayed those points. Okay, so that's what graphing calculator does. It can do advanced computations, put it in a nice format for you, and tell you what the answer is. And then as far as graphing, you mathematically tell it what points you want. It shows those points. That's in a nutshell what GC does. Okay, any questions? All right, so in the next hour, I'm gonna get Canvas organized, get the syllabus done, and then so all you have to do is go to Canvas, and like say after 2:30, go to Canvas. It'll have everything you need, and it'll tell you what you should do for Tuesday. Okay? Any questions? It's a fun course. Get ready. It's hard though. It gets hard. So we're gonna start off with easy stuff like this, but then here, let me. As you're walking out, let's show you one more thing. Yeah, I'll tell you. I'll show you Tuesday. So I'll show you Tuesday some of the stuff that you'll do by the end of the semester, which is Pretty sophisticated, hard stuff. But it's all about knowing the mathematics. If you know the mathematics well, and you type it in correctly, and then it will produce exactly what you tell it. All right, have a great weekend. Be safe.